This lesson will cover Lesson 59 and 60. Let's review from Lesson 58. Lesson 58, Part 2, involved constructions. The first construction was the first one here of Lab 8 on page 387 in your Saxon Geometry textbook. So the first one is construct a tangent line through a given point on the circle, and this was circle A with a point on circle B. So we constructed that tangent right there. On the next drawing that you made, you construct two tangent lines to a point external to the circle, the point P, and we chose that point and we made two tangent points. Looking like the final drawing right there, drawing 5. Two tangents after we constructed a midpoint and then a circle from that midpoint that had a radius of MC. Just so you see that, and there's more lab practice there. If you felt that you would like to do more, there's a line tangent to D at point A, and this goes through more practice. Excellent. Lesson 59 is finding surface areas and volumes of prisms. It says new concepts is surface area. As long as we understand lateral faces, bases, recognize the lateral edges, and that the lateral area of a prism is the perimeter of the base and the height of the prism and the prism's height, then I feel that this would be a lesson that is adding rectangles, and you're quite good at that. Going on to Lesson 60. Lesson 60 is proportionality theorems. And I'm going to scan down to our paper. Proportionality theorems is on page 396. Previous lessons in this book have presented some proportional relationships within triangles when they are divided by a mid-segment. I put a star there for a special case of mid-segment. Now we are introducing the relationship for any line that intersects two sides of a triangle and is parallel to one side. You'll notice that A is not a midpoint of XY. So this line is parallel to YZ, and it intersects the triangle at 2 points. So right here we say AB intersects triangle XYZ at points and is parallel to side YZ. Well, on the left side of the triangle, we first have the top half, which is segment, which is XA. And on the bottom half, we have AY. So XA over AY. And on the right side of the triangle, we take the top half, XB is to BZ, top half to the bottom half. This is theorem 60-1. So this proportionality can be used to help us find lengths of sides. Like any proportion, we can also say, before we had top left to top right, bottom right, we can also say top left to top right and bottom left to bottom right, which shows X to A over XB and AY over BZ. To continue, we have the converse of the triangle, and that is theorem 60-2. If the line divides two sides of a triangle proportionally, then it is parallel to the third side. So if we say that this side is 2-1 and this side is 2-1, then we know that this is parallel to YZ. Stated in the equation, if X to Y, XY, I'm sorry, it's an A, XA, segment XA, over segment AY equals segment XB over segment BZ, then AB, line AB, is parallel to segment YZ, or side YZ. That shows the theorems. The examples that we can show we're done with labeling the triangle up here. If I say that this side is 2, and this side is 1, and this side is 3, and this side is 1.5, let's say that we didn't know 1.5, and we were trying to find BZ. We would say that 2 is to 1 as 3 is to BZ. So 2 times BZ, remember, we can cross multiply. 2 times BZ equals 3 times 1. Divide both sides by 2, and we get BZ equals, that's 3 times 1, equals 1.5. And going back to our example, that's what we had it as. So it is proportional. This is 2 to 1, this is 2 to 1. Very good. Theorem 60-3 adds another line, adds more parallel lines. Two scalene lines, obtuse, they are not parallel to each other. AB, CD, make our lines. All lines have arrows at both points. I'm going to put the wide arrow indicating that means that they are parallel. These parallel lines intersect our transversals. We remember two parallel lines with one transversal. Now we can use our proportionality theorem to say that the EF is finished. We can say that AC is proportional to CE as BD is to DF. That is the lesson, and I wanted to turn to page 400 and do problem 11. On page 400, I'm going to show the drawing in the book and say that the circle shown has center A, segment AB is a radius, and Mariah, the student, has calculated that angle A, or BAD, is 65 degrees. And our job is to find why her conclusion is invalid. The reason, now, looking at it, we assume, and Mariah assumed, that angle ABD, where it meets right here, was assuming that's 90 degrees. Not only is there no point there, but we don't know if that is 90 degrees. Therefore, the assumption cannot be proven to be a tangent line from what is given. From what is given, it cannot be proven. Therefore, it is just assumed, and her assumption is invalid. We need to illustrate now with the sling. Illustrate the concept of tangent with the sling. With the sling David used. If we have David in the middle as the little dot, and he's swinging the sling centrally around his head, and it's going round and round, wherever he releases it is the tangent line. And so it will go out, and if this is Goliath, it will hit Goliath. If he releases it one part differently, it takes a different path. we cannot release it here and have it take a non-tangential path. Similarly to your wheels being on the ground. If you see your wheels on the ground, it touches at a point of tangency. It's not going to touch somewhere off. Now our wheels actually do compress, and it doesn't have exactly one point, but we are talking about the perfect point of tangency, and that is where all the forces of the car are coming down on, same as where that radius would be. If this was a car wheel, all the weight from the car on that wheel is coming down to that point. That is one reason why your tires, very important that they have good tread. You've got 4 wheels, not in this illustration, you've got 4 wheels on your car, and those 4 little points are the only things holding your car on the road. So those tires at those points, no matter where we are after it's circling around, there's a weak spot on the tire, and that's where you are. That is the only point holding you on the road. Thank you very much. We will continue with the next lesson. Have fun with your lesson.